What's going on, guys? I wanted to address the minimalist design of the Mesclatore Solventless. So I've seen so many machines that have 1,000 doodads, actuators, and pneumatically powered valves and electrical valves and switches and all sorts of electronic equipment that looks amazing. It really does. However, my opinion is that a minimalist design that gets the job done as efficiently and as quickly as possible is the way to go without complicating the engineering by using too much sophistication, too many parts that at the end of the day can and will break and at best need to be constantly maintained. So let's have a look at some of the features, how we do things and why. So let's start with the drive. So this motor and this gear reducer do not need to be maintained until they fail. And so the lifespan of these motors, of course, will depend on how many hours you use them, but they don't need to be lubricated. There is no maintenance that needs to happen on these motors. And when they do fail, they're a relatively inexpensive replacement. Some other machines might use all sorts of devices that need to be maintained, which will just increase the operating cost and the downtime of the system. We don't have any of that. And as you can see, our drive is pretty simple. Motor, gear reducer, shaft, done. There's no lubrication. There's nothing that needs to be done in order to keep this machine operating. That's really it. And so some of the machines that I've seen on the market will have sophisticated cleaning mechanisms. Again, all of those valves, all of those systems have to be maintained, they have to be lubricated, and they will break down. If you notice in our trolley, it's pretty simple. Trolley is one piece that can be changed, and it does not have any complex systems that need to be maintained. The AODD pump does need to have the diaphragms changed. It's about a 30-minute to an hour upgrade. After a certain number of cycles, I believe it's 10 million cycles, you need to service the diaphragm pump. But even if you have a damper, in this case, this customer has a damper, and the damper is no maintenance. Very simple, passive damper. Again, valves. This is the temperature probe, and this temperature probe can actually just be eliminated if you don't want to use it, but there's no maintenance involved here. It's a very inexpensive yet effective temperature probe that logs the temperature in your system if you're using a pro system. The pneumatics that we use to lift our system, again, extremely simple to use and operate. They are sealed in this box, so you don't have to touch it. Nothing here to maintain. PLC, again, nothing to maintain here. Here's a pneumatic lift. So this cylinder here lifts the motor, the drive, and it does have rollers here and here. And so this surface needs to be lubricated from time to time just to keep that rollers in there, but the rollers inside don't actually need to be lubricated. So there really is very little maintenance that actually needs to be performed in this machine, and there are very few pieces that can break because we all know that if anything can, it will inevitably break. So just keep that in mind when you're looking for a system that, although all of the electronics look really cool, there is a downside in increased costs of maintenance and downtime because all those systems add complexity. There's extra training that needs to go into having users learn how those systems operate. And we don't use those systems because they are not necessary. We perform all of those functions without having any sophisticated components. The only sophisticated component is a computer-controlled programmable logic controller that does GMP data logging and things of that nature. But everything else that you need is right here. Smart engineering from extremely talented engineers in Arezzo, Italy. Thanks for watching.